Hello, I am going to be giving a walkthrough of my fall 2019 CFD project, and it is for a Bernoulli gripper. So to start with, you'll take a fluid flow block here and make a standalone simulation and start a design modeler geometry. So we'll pull up what I have started here. So I don't want to do this drawing live on camera, but you can see all of the dimensions here and where they go here. So a couple of notes if you're trying to repeat this is and yeah, go ahead and pause the video here to make the drawing and do all these dimensions. But a couple of notes here. This one's H7. It's kind of hard to see. This arc here, R10, is tangent on both sides. So however you need to do that with a tangent constraint, or do a fillet here if you can. And then this distance, H13, is from this line over to the next one. And then there's actually no line, this is important for later, connecting these two. So this whole sketch is one continuous line. And that lets us do our next step. We can take our sketch, go to concept and surfaces from sketch and generate. So now we have a surface body and we still have the sketch. Now we can open our surface there and let's start selecting lines. So we'll make several named sections. So first, let's see here. We'll make I'm just looking at notes here to make sure that I am getting these all the exact same way so it doesn't mess us up later. Okay, make a name section here. And this will be called do name section and apply geometry. And we'll give this a name outlet. Okay. The next section we'll do is the inlet. Go here. Same story. Oh, we need to generate again, apparently. In section. Inlet. Generate. And then we'll do axis. So this is an axisymmetric model. And so we need to always use the positive x-axis as the axis for any axisymmetric model. I don't know why, that's just how Ansys does it. So we'll give this a name, axis. Next, we will name our CD. So this is actually the cross section, and CD is in compact disc. This is actually the cross section of a CD if you revolve it around the x-axis, if that makes sense. And that's important later. Call this CD. And generate. And last one, we'll create the name section for the wall. That's here. Don't forget the little radius. Okay, and section and wall. And generate. And with that, we should be done with Design Modeler. We can close this out. And we will open up our mesh. Feel free to watch this on ×2 and speed it up and then pause it as needed. Watching through this could be pretty painful without doing that. Okay, we have our meshing software open. And now the meshing that we use for this project is actually very simple. We only have one mesh control. We'll go ahead and generate the mesh as is. It's very simple. Here we go. So then we actually need to do a mesh control. We'll insert a sizing here. And then for a geometry selection, I need to move these zoom tools somehow. There we go. Okay, so now we're able to do an edge selection. And we select 4 edges for the sizing. So we'll click here, here, and then the little radius again, and here. So for the element size, we'll do, oops, I did not apply this geometry. Apply, there we go. For element size, it will be 0.123455. See if that works. That looks good. And in meters here, even though everything else is in centimeters, make sure that this super tiny mesh size is in meters. Behavior soft is fine. And then we'll change the growth rate to 1.05. Okay, and now we are ready to generate the mesh. And this, at least for my computer, takes a very long time. But just be patient with it and do something else. And I will be back afterwards to do the rest of this project in a separate video.